The last video poster is AI-enabled low-cost stethoscope by Pratyush MALLICK, his firmware engineer at Analog Devices.
Hello, I'm Pratyush, and I'm going to speak about a specific use case of tinyML, that is AI-enabled low-cost smart stethoscope. As the second wave unfolded throughout the world, surviving through the pandemic became an everyday challenge. People started adopting telemedicine, however, they had to visit clinicians for physical examination and diagnosis. The first and most important symptom of COVID-19 was development of respiratory abnormalities, for which people still had to visit clinicians, which increased their risk of getting infected. What if we could avoid this step? What if the normal stethoscopes could reveal the abnormalities in the functionality of lungs by listening and analyzing the sound patterns, just like a doctor? With all these questions in my mind, I developed a proof of concept to detect COVID-19, the symptoms of COVID-19 and wheezing at the edge. In order to achieve this, a normal stethoscope was used, which was cut at the end and was connected to a microphone amplifier. The output from the microphone amplifier was connected to the ADC of the MCU. The hardware platform is based around wyoterminal, which is an all-in-one platform for developing and prototyping, which supports Arduino IDE as well as has an inbuilt LCD and a micro SD card. For data collection, the microphone was placed on specific auscultation points from which data was collected from for normal breathing patterns of the sounds of the lungs as well as for wheezing. However, for the COVID symptoms, it was quite risky to collect data from an actual patient. So the lung sound of a COVID patient was simulated through a speaker and recorded through the stethoscope. The data is collected through the wire terminal via the SD card support. The data is then uploaded to the Edge Impulse, which is an online framework tool which helps acquiring and training modeling data as well as deploying it at the edge. As the lung sound belonged to a lower frequency spectrum, so the data collected was sampled at 16 kilohertz. The actual frequency range of lung sound ranges from 300 Hz to 2000 Hz. So a software filter, bandpass filter, was designed in the pre-processing stage using the Edge Impulse to filter out the sound of our interest. The time series data after being split is fed into the MFE block. So here we are using MFE block rather than MFCC block, which are quite similar. However, MFE block is suitable for non-voice audio classification. The MFE block makes use of a non-linear scale in frequency domain, which is called MEL factor. The output from the MFE spectrogram is fed into the neural networks, which is then gives us the output for output features classification. This is the neural network architecture. On the left hand side, this is the default 1D convolutional layer that the Edge Impulse supported. And on the right hand side, you can see the model performance. The performance is quite well for detection of COVID and wheezing. However, for the normal data set, I guess more improvement can be made. However, the overall accuracy is quite nice. So this is the proof of concept. So the wire terminal has 3 buttons which can be used to navigate through the UI, which uses LVGL. So as soon as you press the button, the device starts collecting the lungs data through the microphone that is connected to the stethoscope for 1.5 seconds and shows the inference at the edge. So it basically classifies into idle state, normal state, COVID state or wheezing state. Idle state is when the microphone is not in use. So for the future scope, I would like to collect more data on real patients of COVID and also to increase the number of classes that the whole device can detect so that it can be placed in any of the crowded places so that people can come and check their lungs at the edge. For more information, you can contact me or LinkedIn, and you can also find more details on the project on Hackster. Thank you.
Thank you, Pratyush. It's actually very, very interesting too. Just a question on the data sets, because I think data sets are quite important to get the accurate model. What kind of data sets you use to train the system?
So for the rest of the model, apart from the COVID dataset, for the wheezing classes, we met a patient and collected the wheezing dataset. As well for the normal dataset, we collected around 10 people for the normal breathing and asked them to normally do a cycle of exhalation and inhalations for 1.5 seconds. And for the idle dataset, we kept the microphone in noisy environments as well as in other environments.
I see. So those datasets, COVID datasets, are they public? And how many samples are there? Do you happen to know?
So the dataset so there's a public dataset as well as the dataset that I have collected is available on the Edge Impulse model. So the model is open, has a public link, so you can download it from there as well.
Got it. And in terms of false positives, do you have any numbers for the false positives for this particular model, for this data set?
So for the false positive numbers, there was one class for the normal class where the false positive was around 16%. So I think I need to work on this and reduce that as well with more number of data sets and good quality data.
Yeah. Good. Okay. Well, thank you. It's a very, very good.
Thank you.
We want to thank especially our strategic partners who have made it possible. We have our executive sponsors, ARM, the Software and Hardware Foundation for tinyML, then Edge Impulse tinyML for all developers, Qualcomm AI Research, advancing AI research to make efficient AI ubiquitous, Sentient end-to-end deep learning solutions for tinyML and Edge AI. Then platinum sponsors, Reality AI, add advanced sensing to your product with Edge AI, tinyML. And then Renaissance, broad and scalable edge computing portfolio. Our gold sponsors, Latent AI, adaptive AI for the intelligent edge. Maxim Integrated, enabling edge intelligence. Seed Studio, the IoT hardware enabler. SensiML, build smart IoT sensor devices from data. SynSense, build sensing and inference hardware for ultra-low power embedded mobile and edge devices. And our silver sponsors, Aeon Devices, Deep Light, EMSA Visual Sense, Greenwaves Technologies, Gravity Inc., HODG, Imagimob, Kixo, Rixen Technology, and SAP. So thank you everyone for staying with us today and see you tomorrow.